Hello to one and all. Today we are going to be discussing a few problems on complex numbers. So to understand the questions more concretely, I have prepared for you the theory prerequisite that is required to solve such kind of problems. So let us skim through this one by one. So the first requirement is basic maths like the quadratic equations and arithmetic mean and geometric mean inequality. Now I'm not going to be extrapolating it further because I want to keep the length of this video short and concise. So the second prerequisite to understand the questions is the geometry of complex numbers. Now let's say a complex number z is represented by x plus iy. So the x is the real part of the complex number and y is the imaginary part of the complex number. Now when I plot this on an Argand plane, uh, the x-axis represents the real part of the complex number and the y-axis represents the imaginary part of the complex number. So I can plot it on the Argand plane like this. So the first point that we need to be aware about this is the condition for 3 points to be the vertices of an equilateral triangle. Okay, so let's say there are three complex numbers, namely Z1, Z2 and Z3. Okay, they represent 3 points on an Argand plane, and when I join all of them together, they form a triangle. Now, for this triangle to be equilateral, there are four conditions that it needs to satisfy. The first condition is as follows, which is mod of z1 minus z2 is equal to mod of z2 minus z3 is equal to mod of z1 minus z3. Now, what this says is mod of z1 minus z2 is nothing but the distance between the points of z1 and z2. That is mod of z1 minus z2. Now, this formula is nothing but telling us that all the sides of the equilateral triangle are equal in length. So this is mod of z1 minus z2, this is mod of z2 minus z3, and this over here is the distance between z1 and z3, which is nothing but z1 minus z3. Okay, so this was the first formula, and when I square and solve this, I get the second result, which is also something that is very standard in its nature, and you guys need to keep it in your mind. And the third result is actually very important. If this result is given to you in a particular problem, you need to analyze that the z1, z2 and z3 points are representing the sides of an equilateral triangle. Now moving on, you also need to keep the fourth formula in mind. It is not used very much, but it is pretty standard in its nature. Now what you need to observe here is omega represents the cube root of unity. Omega represents the cube root of unity. Okay, so these are the four conditions that are satisfied if Z1, Z2, Z3, 3 points on the complex number represent the sides of an equilateral triangle. So moving on to the third prerequisite, that is some formulas of complex numbers that you need to be aware about. So the first formula is Z conjugate is equal to mod of Z square. Now, if Z is represented by x plus iy, z conjugate is represented by x minus iy. So if I multiply z and z conjugate, I get mod of z square. Now recall mod of z square is nothing but, if z is x plus iy, then mod of z square is nothing but x square plus y square. Okay, so moving on to the second formula, which is mod of z1 plus minus z2 ka square. So there are two complex numbers z1 and z2. Their square is equal to mod of z1 ka square plus z2 mod of z2 ka square plus 2 times real part of z1 z2 prime. Z2 prime is the conjugate of z2. Now, it is important for you all to note, because in some books a different formula is given. Instead of z1 z2 prime, it is given z2 z1 prime, right? So actually the real part of z1 z2 prime is equal to the real part of z2 z1 prime. Why is that so? You can observe that if I take the conjugate of z1 z2 prime, we are left with nothing but z2 z1 prime. Okay, so this number, this complex number actually is the complex conjugate of this number. So actually the real part of both the numbers will be same. So moving on to the third formula, it is that mod of z1 plus z2 plus z3 ka whole square is equal to mod of z1 square plus mod of z2 square plus mod of z3 square plus 2 times real part of z1 z2 prime plus z2 z3 prime plus z3 z1 prime. So these are the three formulas that you need to keep in your mind because they are very useful in solving such type of problems that I'm going to discuss later in this video. So the fourth formula that you need to keep in mind is the section formula in complex numbers. Now suppose there are two complex numbers in the Argand plane that are defined by z1 and z2. Now these points, now suppose the line joining these points, there is a point z. Now this z is dividing z1 and z2 in a ratio of m is to n. To find the coordinates of z in terms of z1 and z2, there is a formula for it that z is equal to m times of z2, which is z is equal to m times of z2 plus n times of z1 upon m plus n, where m and n are the ratio in which it is being divided. So at this point, you are well equipped to tackle the problems that I'm going to be discussing today. So let us move on to the problems. So let's look at the question statement of the first problem. Let z omega belonging to complex number be such that z plus omega is equal to 8 plus 6i. This is what we've been given. And mod of z minus omega is equal to 4. Find the maximum value of mod z plus mod omega. Okay, so let's look at the solution to this question. So first of all, we have been given that z minus omega is equal to 4. Now notice z and omega belong to complex number. This is what we have been given. And since I have got no formula on this, I'm going to take the square. So this implies that mod of z minus omega ka square is equal to 16. Now mod of z minus omega ka square is going to be nothing but z square ka mod plus omega square ka mod minus 2 times of real part of z times omega prime. That is the complex conjugate of omega. Now, we have also been given z plus omega. So, we have been given z plus omega is equal to 8 plus 6i. So, what I'm going to do is I'm going to take the mod of z plus omega. So, mod of z plus omega is, and I'm going to take the square of it, is equal to 8 square plus 6 square, which is 64 plus 36 is equal to 100. So mod of z plus omega ka square, when I expand this, this is going to be mod of z square plus mod of omega square plus 2 times real part of z omega prime. Okay, so I want you to look at both of these. So you can clearly notice if I add 1 and 2, I'm going to be left with 100 plus 16. I'm going to add the left hand side, which is going to be 116 is equal to 2 times mod of z square plus omega square. Come on. So this 2 times real part of z omega prime is gonna cut with each other because they have the opposite signs. So what I can say is mod of, this is, I'm going to write this down here, mod of z square plus omega square is equal to 58. This result I'm going to use in the future. Okay. So what is it that we need to find? We need to find the maximum value of mod of z plus mod of omega. So let sum k equals mod of z plus mod of omega. So observe, when k attains its maximum value, k square will also attain a maximum value, right? If k assumes its maximum value, K square will also assume its maximum value. So what is K square? K square is mod of Z plus mod of omega ka whole square. Mod of Z plus mod of omega ka whole square. Now, since there is a mod, these both can be treated as real numbers, right? Positive real numbers. So mod, we are going to use the formula a plus b ka whole square is equal to a square plus b square plus 2ab. So k square is going to be nothing but mod of z square plus mod of omega square plus 2 times mod z times mod omega. Okay. So z square plus omega square is equal to 58 is what we have been given. So what I can say is k square is equal to 58 plus 2 times mod z times mod omega. Okay, so I need to find the maximum value of k here, right? I have to maximize k, which means I have to maximize k square. So this means since this is a positive number, mod z is positive, mod omega is positive, I have to find the maximum value of this here. So what I can do here is I'm going to use the concept of AMGM, which is that the arithmetic mean is always greater than the geometric mean, always greater than or equal to the geometric mean, right? So I'm going to use this on z square mod comma omega square mod. Okay, so what I can say, the arithmetic mean of this is mod of z square plus mod of omega square upon 2 is always greater than equal to uh, the geometric mean, which is nothing but mod of z square mod of omega square raised to power 1 by 2. So once I put the 2 on this side, what I can say is, and once I replace mod of z square plus mod of omega square is equal to 58, which is what we found out earlier. So 58 is greater than equal to 2 times mod z mod omega, which is what we have right over here. So the maximum value that this thing can assume is 58. Okay, this will always be less than or equal to 58. So since we have to maximize k square, I can say k square max is equal to 58 plus the maximum value of this, which is 58 plus 58, which is equal to 116. So I can say k max is equal to root of 116. Now this is nothing but 4 multiplied by 29 ka root. So this is 2 root 29, and that is the required answer. So I can say the maximum value of mod z plus mod omega, which was equal to k, is 2 root 29. And that's it for the first question. Let's move on to the next question. So let's look at the next question. So in this question, we have been given with a complex number z, which satisfies the given equation, and we have to find the minimum as well as the maximum value of mod of z, right? So what I can do is, let's look at the solution to this particular problem. So before I begin with the solution, I want to tell a very standard result uh, which I'm going to be using in this particular problem, uh, which you guys need to keep in your mind. So suppose I have two complex numbers z1 and z2, then they will always follow the certain inequality that I'm going to be writing down right now. So this is what I'm going to use here. So what I'm going to do is I have been given with mod of z square plus 4 is equal to 2 times mod z. I'm going to bring this z on the other side and I'm going to divide it all together. So what I'm going to be left with is z plus 4 by z ka mod is equal to 2. So this looks similar to this kind of presentation over here. So what I'm going to do is I'm going to let z1 is equal to z and z2 is equal to 4 by z in the given inequality formula. So what I'm going to be left with is mod of z minus 4 by z is less than equal to and instead of mod of z1 plus 4 by z, I'm going to replace this with 2 because this is equal to 2 as in the given question, right? And this is always less than equal to mod of z1 plus 4 by z. So this is mod of z plus 4 by z ka mod, right? So what I can do over here is I'm going to replace let mod of z is equal to x. Okay, so notice in the initial question we had to find mod of z, the minimum and maximum value of mod of z. So we are going to find the minimum and maximum value of x and we are going to be done. Okay, so let's look at this part of the inequality and try to solve it using quadratic equations. Okay, so what I can say is mod of x minus 4 by x is less than equal to 2. So to find the minimum and maximum or the extreme values, I'm going to take the equality sign. So this is equal to this. So what I'm going to do is I'm going to solve this quadratic equation right here. So I'm going to be left with mod of x square minus 4 is equal to 2 mod x, right? So I'm going to take the whole square of this. I'm going to be left with x4 plus 16 minus 2 into 4, that is 8x square is equal to 4 times x square. So what I can say is x4 minus 12x square plus 16 is equal to 0. So this is a quadratic equation in x square. So what I'm going to do is I'm going to take x square is equal to y. So this whole equation is nothing but y square minus 12y plus 16 is equal to 0. So what I can say is y is equal to 12 plus minus root 144 minus 4 times 16, that is 64 divided by 2. So on simplifying, so root 5 to this is going to 6 plus minus 2 root 5, right? So what I can say is y is equal to, so this is going to be, when I simplify this, this is going to be y is equal to 6 plus minus 2 root 5. Since y is equal to x square, I can say x square is equal to 6 plus minus 2 root 5. Now notice what I'm going to do here is I'm going to write 6 plus 2 root 5 as root 5 square plus 1 square. This is nothing but 6 plus minus 2 times root 5 times 1. So this is going to be nothing but 6 plus minus 2 root 5, which is x square. This is going to be nothing but root 5 plus minus 1 ka whole square, which is equal to x square. So I can cut the x square part and I'm gonna be left with x is equal to root 5 plus 1 and root 5 minus 1 as two of the values of x. And notice that x was nothing but mod of z, right? So the maximum value of z, mod z is going to be root 5 plus 1 and the minimum value is going to be root 5 minus 1. Okay, so this is going to be the max, this is going to be the min. So this is the kind of approach using that inequality formula that we solve such kind of problems. Now notice I haven't used this part of the inequality. So there are going to be two solutions from this part as well. So let's see what happens here. So mod z is equal to x, I can say 2 is equal to x plus 4 by x, right? So I'm going to do is I'm going to say 2 is equal to x square, that is 2x is equal to x square plus 4. So what I can say is x square minus 2x plus 4 is equal to 0. So notice the discriminant. Discriminant is going to be minus 2 square, that is b square minus 4ab minus 2 square minus 4 times 1, which is less than 0. So there is going to be no solution for mod z, that is x here, because mod z has to be greater than equal to 0 and it has to be a real number, right? So since the discriminant is less than 0, there is going to be no real solution to this. Therefore, our final answer is going to be that the maximum value is root 5 plus 1 and the minimum value is root 5 minus 1. So that was it for the second question. Let's move on to the next question. So there are two more questions that I would like to discuss with you all. So I'm going to be discussing it in the part 2 of this series. So you can try it out for yourself first. And if you don't get it, then I'm gonna upload the solutions real soon. So that was it for the first part of this video.